module. So we're going to begin with review of what? Of angles and triangles. Why do we have to review angles and triangles? So first, we try to define trigonometry. So for you to understand why we need to review angles and triangles. What is trigonometry? Do you have any idea of what trigonometry is, guys? What is trigonometry? Anyone? Can you speak if you want or participate? So what is trigonometry, guys? Guys, what's trigonometry?
Sir,
Yes.
is it the study of triangles, their angles, and their relationships po?
Yes. Okay. So trigonometry is the branch of mathematics. So it is a branch. Thank you. Very good. It is a branch of mathematics dealing with the study of the measurements of the parts of the triangles. Dealing with the study of the triangles and the measurements of their parts. So dealing with the study of triangles and the measurements of their parts. Triangles and the measurements of their parts. And when we say parts, we mean what? What parts are we referring to the triangles, guys?
Sides and angles po.
The sides and angles. Sides and angles. By the way, who was your instructor in Gen Math?
Sir Roy Concepcion po.
Okay. He's also from the math department. So sides and angles. Trigonometry also deals with the study of those periodic in nature. Those phenomena that are periodic in nature. Deals also with the phenomena or occurrences. Phenomena that are periodic in nature. In nature. So what do we mean by this? By phenomena, so these are occurrences or events that you will see something that is repetitive in nature. Like for instance, Earth revolving around the sun, no? So that is periodic in nature, meaning it repeats every year, no? The what is happening. The current of the sea. So the current of the sea is periodic also in nature, meaning same shape, no, as it waves, okay? And also the vibration of a string, pendulum, motion of pendulum. So these are the things that are periodic in nature. So trigonometry also deals with such. This phenomena can be modeled by what we call trigonometric functions. Like for instance, the motion of pendulum, the vibrations. When they are modeled, they are represented mathematically involving trigonometric functions, especially sine, cosine. So in other words, you don't only study trigonometry applying to triangles. So in in phenomena that are periodic in nature, there are no triangles here. So, but it is what? It is something, it's a behavior, no? So, and the behavior is being periodic. Let's have here. So here, motion of pendulum, motion of pendulum. What else? Vibration of spring and vibration of spring. Orbit of orbit of Earth, no? Around the sun. And many more. The word trigonometry comes from two Greek words. And these are what? What are the two Greek words where trigonometry comes from? Guys, trigonometry, anyone? Comes from two Greek words. Two Greek words. What are these, guys? What are they? Guys.
Sir,
Yes.
trigonon and metron po.
Trigonon and
Metron.
metron. Trigonon and metron. So what do you mean by trigonon? Trigonon, what does it mean? And the other one, metron. What's the difference? Iho, what's the difference?
Sir, trigonon means triangle po, and metron means measure po.
Triangle. And then metron means?
Measure.
Sorry?
Measure, I think.
Measure.
Is it measure?
What in particular? To measure or a measure?
Measure. As in suka.
Okay.
Measure po.
Because it depends on the word used, no? Whether metron, metria, metrein. When you say metron, means what I know to measure. So what I know, but I'm not really sure. Metria means measurement. If you say metria, it means measurement. And then if you say metrein, it's a measure. Okay? So possible because there are books instead of the word metron, they use metria. And if they mean metria, it means measurement. And metrein, normally I think it's a measure. And then metron to measure. Okay? So other words, you have metrein, and then metria. Yeah. So this is a measure. So this one, a measure. While this one is measurement. Measurement. Okay. So going back to the definition of trigonometry, dealing with triangles, and their parts, sides and angles. So we need to recall sides and the definition of angle. No? So what is an angle? Do you still remember what an angle is? Guys? What is an angle? What is an angle? Guys, anyone? What is an angle?
Hello, sir.
Yes.
It's like the space between two intersecting lines.
It's like what? Again, sorry.
The angle is like the space between two intersecting lines.
Two intersecting lines. So it is a union. Yes, it is a union of two rays or lines or sides, no? Meaning sides, no? Or lines. Meeting at a common point. And this common point is called what? Common point called
Vertex, sir.
vertex. Right. Good. Called a vertex. So that's what we mean by angle. So we have, I don't know what's happening. I can't see the arrow in my, wait. I'll have new share again. Yeah, okay. Do you still see the board, guys? Guys,
Po.
do you still see the board?
Yes po.
Okay. So we have, let's say, I have a point. By the way, in your Gen Math, so how how was the presentation of lecture? Did your teacher write also or PowerPoint presentation?
For Gen Math po, may presentation na po na naka-prepare si Sir Roy. Tapos, he had another app po for
Okay.
the drawing.
I normally write because I want it to be like in a classroom setup. So these are two rays, and this is the vertex. Okay, so let's take a point here. For instance, this is A, and this is B. No? And this is, let's say, theta, the angle. Okay. So we say the measure of theta or just theta. So angle theta, angle theta. And the measure of that is supposedly measure of angle theta or simply theta. Or simply, we don't write anymore, unlike in geometry. We have measure of angle theta or simply theta. The name is theta, and normally the value is also the theta, no? I mean, we are going to have just equal to theta. Angles are classified according to the size, no? Size of or amount of rotation. So what are the kinds of angles as to amount of rotation or size? So kinds of angles. Can you name some?
Obtuse angles, sir.
So as to size, no, or amount of rotation. Size, that is amount of rotation. Amount of rotation. Number one is what, guys? Again?
Obtuse angles, sir.
Obtuse angle. What about smaller than that?
Acute angles, sir.
So we have acute. Acute angle. Acute angle. And this measures what?
Less than 90 degrees.
Measures between what?
Between 0 and 90 degrees, sir.
Between 0 and 90 degrees. Number two. So we have like this, no? So this is the angle. So that is acute, this angle. What about number two? We have right angle, no? Right angle. This measures what?
90 degrees.
90 degrees. So we have two perpendicular lines. And we normally put square to mean, small square there, to mean right angle. What about number three? We have obtuse angle. So what is an obtuse angle, guys?
Anything more than 90 degrees po.
So between 90 degrees and 180 degrees na, right? Then if there are other special, if let's say there is no movement between the lines, so we have what we call zero angle. No? These are special angles. Zero angle measures 0 degree. Then we have, so obtuse angle, by the way, obtuse angle. So this is the obtuse angle, and we measure it here. Then zero angle, we have this. So this side does not move. Now, but of course, to elementary, we don't talk of this, no? So they just talk about acute, right, and obtuse. So we have level of understanding. Number 5, we have straight angle. What is a straight angle?
I think it's an angle that measures exactly 180 degrees, sir.
180 degrees. Now, to elementary, for instance, elementary, they don't consider angle like this, no? But to once you take geometry, so it is possible that this straight line considered angle. Okay? So, but again, depending on the level of understanding, you don't talk about this angle in grade 3, grade 4. So, but to your case, so we can talk about this now. So we have so this is let's put arrow and point here. So this measures 180 degrees. Number 6, we have reflex angle. What is a reflex angle, guys?
An angle between 180 degrees and 360 degrees, sir.
Measures between 180 degrees and 360 degrees. So if I have an angle like this, and you don't measure it, normally we measure here, no? The smallest amount that we can have. But if you measure it this way, so we call this reflex angle. So if I have and then you measure it here, so we have a reflex angle. Okay, so these are the kinds of angles as to size or amount of rotation. We can also classify angles as to what? Angles as to kinds of angles as to relationships. So angle relationships. Angle relationships. What are they? Guys? What's the first one? We have complementary. What is a complementary? What are complementary angles?
Two angles adding up to 90 degrees po.
angles whose sum
90 degrees.
Is 90 degrees. And then number 2, what about number 2? So by the way, if I have, let's say, this angle, and you divide it into 2 parts. So let's say this is 90, and you divide it into 2 parts. So we form what we call complementary angles. Okay, so this angle, let's use other color. And then the other angle, okay, this angle. So this, let's say theta, and then the other one, let's call this beta. We say that beta is what? Beta is a complementary angle of theta, no? Meaning theta and beta are complementary angles. Theta and beta are complementary. What else, guys?
Supplementary angles.
Supplementary angles. So when you say supplementary angles, these are 2 angles. Whose sum is what?
Their sum is 180 degrees.
Is 180 degrees. So if I have a straight angle, and let's say I divided this into 2, our neighbor is having house renovation. The carpenter is poking the wall. So we have, again, this angle, then the other one, this one. So this is, let's say, alpha, and then let's say this is gamma. Is it gamma? That name. So this alpha and what? And gamma are supplementary angles. Okay? So the sum is 180. Number 3. What else? What if the sum is between 180 and 360? What do you call that? Let's say the sum is 360. The sum is 360. Huh? What is that angle of sum is 360? Guys. guys, again, let's call it theta. And this one,
Supplementary angles po.
sum is 360. Huh? Sum is 360. What angle?
Conjugate angles.
Conjugate angles. Conjugate. Or they are called explementary angles. Explementary or explementary angles. So what are explementary angles again, guys? Sum is what? Two angles whose sum is 360 degrees. Okay? Yan. Now, from these angles, we can classify triangles also, no? So, similar to classification of angles normally. Now, but so let's have triangles. So again, what is a triangle? What is a triangle?
A polynomial with three sides.
So it is a polygon with three sides. Three sides. Yeah. So let's draw a typical triangle. So this is an example of a triangle. Yeah. A triangle has primary or main parts. What are the primary or main parts of a triangle? Of any triangle, primary or main parts. What are the primary or main parts of a triangle, guys? We have starting with vertex, no? So there are three vertices. So how many vertices? Three. Three vertices. What else? If you connect any two vertices, we form what? We form, guys, we form three sides, okay? And then between two sides, we have what we call angles. Yeah. Now, for secondary parts of triangles, secondary parts, these are accessories to the triangles. Secondary parts. Of a triangle. What are the secondary parts of a triangle, guys? Guys, number one. Okay, guys, are you still there?
Guess lang po. Altitude po.
Altitude. Altitude is very important when getting the area, no? Altitude. of a triangle. I'm not going to write the definition anymore. So it is a line segment or a line from one vertex perpendicular to the opposite side. If I have this triangle, so the altitude is this. No? So this is altitude, the yellow, no? Yeah. That is the altitude. Okay. Next, number 2.
Median.
Sorry,
Median, sir.
median. So what is a median again, guys?
It's a line to the
From
it
one
goes
vertex
to the bisect. It bisects the opposite side, right?
bisecting the opposite side, or it is a line segment or a line from one vertex to the midpoint of the opposite side, no? Yan. So meaning, this is equal to this, right? So this is the median. That's the median. Number 3, we have, I don't see you. Where can I see you? Where are the people now? Participants. I don't see the participants now. Oh, here. Chesterton. What's the next one? Chesterton. Kiana Lizzie Bocol.
Hello, sir.
Oh, yes.
Angle bisector.
Angle bisector. It is a line dividing the angle of a triangle into two congruent angles. No? So we have this angle bisector. So we have this, let's say this angle. I'm going to pass a line and we'll get to this angle. This angle is supposed to be congruent to this angle. Okay? So this is angle bisector. That's the angle bisector. Our number 4, last one. Our last one, John Paul Kearney. John Paul Kearney. John Paul Kearney. Carl Chester.
Perpendicular bisectors po.
Perpendicular bisectors. So we have perpendicular bisector. So it divides a side into two what? I mean perpendicularly at the midpoint. No? So we have, doesn't change color. So where is the midpoint? Let's say this is midpoint. So we draw this line and perpendicular to that. Okay? So this is supposed to be equal to this. So that's perpendicular bisector. Yes. What else? So we have kinds of triangles. By the way, these two, these accessories or these secondary parts of a triangle, altitude, when you draw all the three altitudes in a triangle, they meet at a common point, and we call that orthocenter. If you draw all the medians, they will meet at a common point, and we call that centroid, meaning it is the center of the triangle. Angle bisector, if you are going to draw all the angle bisectors, so it will meet at a point always inside, and it's called in center. Perpendicular bisector, they will meet at a common point, all those perpendicular bisectors, the three. So when you draw all of them in a triangle, they will meet at a common point also, which is called circumcenter. Meaning, if you circumscribe a circle about the triangle, the center of the circle is at the intersection of the three perpendicular bisectors, while the intersection of the angle bisectors in a triangle, these three angle bisectors, always inside, that is the center of the circle inscribed in the triangle. Now, for kinds of triangles, what are they? According to sides, you can classify triangles according to sides. So going to time already. What are the kinds of triangles according to sides? Kinds of triangles, guys. Guys, what are the kinds of triangles according to sides? Huh? As to sides. What are they, guys?
Po, right triangle.
So we have, according to sides.
Sir, scalene,
Isosceles.
isosceles, and
Scalene.
equilateral.
Scalene triangle. What else? So scalene triangle, no particular sides equal, no? Oh, yan. I mean, all the sides are not equal. This is not equal to this, and this is not equal to this. Scalene. Number two, no equal sides. No equal sides. No equal sides. What about isosceles? Isosceles triangle.
Two equal sides.
Two equal sides. Two equal sides. Yeah. We have this triangle. So this is supposedly equal to that. Number three, equilateral triangle. Three equal sides, okay? So all the sides are equal. So meaning all the angles are equal inside. So this angle is supposed to be equal to this for isosceles. And we call this vertex, base, and then these are the legs. Okay? Yan, almost time now. Yes.
Excuse me po, sorry, I have a question. Will you post this recording po?
Yes.
Okay, thank you, sir.
All equilateral triangles are, every equilateral triangle, what can you say about equilateral triangle?
They're
Every
equiangular po.
equilateral triangle,
Are equiangular po.
equilateral triangle is an isosceles triangle. Isosceles. But not all isosceles triangle is what? Is equilateral, ha? Every equilateral triangle is isosceles, but not all isosceles triangles are equilateral. And then the last classification we have what? According to, we're now in a hurry. What are the kinds of triangles? Other kinds of triangles according to angles. What are they?
Right,
Guys?
right, acute, and obtuse po.
Right, acute, and oblique. Kinds of triangles as to angles. As to angles. So how many? There are 3. Number 1, acute triangle. Number 2, what's number 2? Right triangle. And number 3, obtuse triangle. You can also consider what we call equiangular triangle, which is acute, no? Equiangular triangle, okay? I saw in FB, kinds of triangles, the answer, student, there was a student who answered Bermuda Triangle, Love Triangle, Ayala Triangle. But I think, if not specified as to what, could that be considered? But the child has sense, no? So imagine he was able to apply. So instead of geometry, it's the physical one, no? Or something that is applied. Okay? So we'll continue next meeting, guys. So this will be this is recorded. Okay now, guys. So see you next meeting. Guys.
Thank you, sir.
Thank you,
sir.
Thank you, sir.
sir.
See you next meeting din po.
See you next
Oh,
week.
sir. See you on Wednesday.
Thank you.